Hi, Sven here. If you've ever wondered how it works that you can use AI image generators to create pictures of yourself like the ones I'm showing you here. For example, me as a samurai, in a suit on stage, in the desert, as a kind of statue, as a cyberpunk, or wearing some kind of old armor. I've never worn anything like that before. As a chef, okay, I do that from time to time, or as an alchemist, or just how I feel when something isn't working right. And how this works, how you can generate pictures like this of yourself, that's what I'm going to show you in this video. So stick around, follow me step by step, and by the end you'll know exactly how it works. It's really not hard at all. I'm Sven, I'm an entrepreneur, and I've been working with quality and process optimization for over 30 years, not just in my professional life, but in all other areas as well. And a lot of what I know and can do today, I've learned through experience or by trial and error. And I know what really works. In my videos, I want to show you how you can ideally implement AI and process automation in your own business. So let's get started. So what are these images, anyway? These images are based on LoRA technology. That's a low-rank adaptation technology. What that means is that an already existing model, so in my case, I use Flux, my favorite image generator, is trained for a specific task. So, we use the Flux image generator and train it with our own photos. And these personal photos form the foundation for the whole thing. So, what you need. I've opened up my folder here. What you need is a whole bunch of photos of yourself. So, about 20 to 30 should be enough, and ideally in a variety of situations, with different facial expressions, like here, for example, or maybe smiling, or close-ups, full body shots, and so on. And once you've put these pictures together, in my case, I'm always wearing a black t-shirt, so there's not much variety in outfits here, but if you wear different things, it'll probably work even better for you. What I learned in the past, I think it doesn't really apply anymore, but I still do it this way, is that I always call these pictures a photo of and then use what's called a trigger word. This trigger word has to be a unique word. I'll get to that later. The image generator can automatically recognize what it's actually about. And here I have Sven and SOAR, that's my abbreviation, and then I added LoRA at the end. So Sven, SOAR LoRA is my trigger word. You compress all these images into a zip folder, and that's basically all the prep work you need to do. Let's move on. So, I'm doing all of this using the platform Fill. Maybe you've already seen this in my videos. For example, I've already worked with image generators on Fill, showed you how it works with the API key, and you also have to deposit a few euros. Right now, I still have about $7 left in my account, and then it's billed per use. That means, whenever you generate an image, a video, or whatever else you do on the Fill platform, it's billed individually. So, it's not a subscription. You can find the model we use for this training under Flux means LoRA minus fast minus training. So you can just search for that on Fill AI. And once you've opened this page, you'll land on what's called the playground, and in this playground, that's where you train this model. The whole process works like this. You use this form here to select the zip file that you generated. That means it's exactly this one here, a photo of Sven, SOAR LoRA. And then we need to enter the trigger word here. You'll need this trigger word later when you want to generate an image using the image generator, because it will reference the object that appears in these pictures. That's why I'm deliberately saying objects. For example, you could also take pictures of these glasses here from 20 different angles and then generate a model with these glasses. That works exactly the same way. So I enter this trigger word here, Sven, SOAR, little LoRA, like that. Then we go to more here, into these additional settings. And now there's also this create masks option, which we'll just leave at the default setting. You can take your time and read through what all of that means. And here, you can set how many steps the model will be trained with. By default, 1,000 are selected here, and if you scroll up, you'll see that you can go up to 10,000. I'm not really sure if 10,000 actually makes sense, but for example, a value like 2,500 or 3,000 is definitely a number with which you can achieve excellent results. So, then also, this is not pre-processed. And here as well, there's no archive format or anything like that. So it really doesn't matter what settings you have here. That means you only have the zip file, the trigger word, and the number of steps. And you can also try it with 1,000 steps, and then maybe later with more. Then you click on Start, and as you can already see here, the request costs $2 per training run. That means, with the corresponding number of steps, this price increases. And if I press Start here now, wait, I'd have to check that first. It's probably like this. If I let it run now and have 3,000 set here, then it should cost me $6. We'll see. We can also track that up here in my final price. Then I press Start and now, it's running. You can see, there's this wait cursor showing loading right now, and any moment now it should appear in this area. Okay, so it took about a minute. And now you can see this training in the log window. You can see it's now marked as in progress. Down there you see one that was already marked as completed. And if I click on See Logs here, you can also see what's happening. Namely, all these images are being processed now. That means it's now reading this zip file, extracting all the images from it, and building the training based on those images. Right now it shows 0%, and now you see, it's at 1%, and now it just takes a few minutes, 5 to 10 minutes, for this training to finish, and then I'll check back in. It took about 10 minutes, and the training is complete, as we can see here by completed. And to use the model now, you click here on Run Inference. Then a new page will open, and on this page you can simply enter your prompt. And as you can see here, the trigger word is already preset. And this trigger word has to appear in the prompt, otherwise the model won't know what to do. That means it'll just generate something random. And I've already prepared a prompt here. So, for example, here I say Sven, soar, and now not test, but LoRA, full body shot, standing pose, and so on, as a gladiator. And, yeah, and then you can set a few parameters down here as well. So maybe I want this in portrait format, and, the number of inference steps, that is, how many steps are used to generate the image, and guidance scale, set to 3.5, and, number of images to 1. And I'll leave everything else as is, or rather, down here I'll set it to JPEG. And, I'll leave all these other parameters at their default values. Then I click on Run. So, and now it takes about 5 seconds. Down there you can actually see what's happening right now. And look at that, Sven is a smiling gladiator, so the intense expression part obviously didn't work. But you can tell that it's me, and I actually do have some kind of gladiator outfit on. By the way, I've noticed that prompts work much better in English, so I always generate them in English. I built myself a little GPT that takes a simple request, like in this case, Sven is a knight in the Middle Ages, and turns it into a detailed prompt. And now, let's see what happens here. So, let's click on Run again. It's absolutely necessary to play around with the prompts and actually try out all sorts of different types of descriptions. For example, do I want a close-up? Do I want a full body shot? And so on. You can also experiment with these parameters here and much more. If you want to use all of this in a make scenario now, you can do that with the regular, quote-unquote, fel AI calls that I've already shown in other videos. But it's very important that you need an extra step here, because when you call this endpoint, specifically this Flux LoRA, as it's described here in the API section, you have to provide this Flux LoRA with the path to your LoRA model. And this path tells the system exactly which model it should use. And, this scale 1, that's also about how strongly the system should actually stick to your own trained model. And I need this part in my scenario. That means, if I now go into the make scenario here, I have a module where I've prepared the variables and this JSON document, which normally starts here at prompt. I then need to add exactly this expression to it, namely the LoRA, then this path that we just saw and copied, with scale set to 1, and the rest stays as usual. So, now it's also about executing this prompt accordingly. Let's just leave it like that, yeah. Sven is a 1970s news anchor and so on. Now I just need to write LoRA here instead of test. Alright, now it's correct again. Then let's take a look at the make a request module. That means I'm calling the endpoint Flux minus LoRA here. And because I specified this path, the system now knows which model to use. Here I have my API key from Phil, and here, this prompt. Alright, let's just run the whole thing. So, the call usually takes a few seconds, 5 seconds at most. Then the image gets downloaded, and then it's uploaded to my Google Drive. Yeah, and if we go into Google Drive here, we can see this image. Well, it's not exactly 70s style, even though maybe the furnishings and the background are, but the suit looks very modern, and the tie even more so. It should actually be this wide. I already made one before where it even gave me hair. Yeah, that's not bad either, of course. So, what have we learned now? We, can train our own model. We can, either use this model directly here in the playground, or we can even use it in our own make scenario. From now on you can use it to generate pictures of yourself, for example as an astronaut or, whatever you want. And, I hope you have a lot of fun with it and I'll see you next time. Bye.